So when we talk about functions, many of us are familiar with things written in slope-intercept form. When we talk about lines saying that y equals, we want y is that output, right? And x is the input. And so when we talk about x's and y's, this is where we work on that coordinate plane where we have an x-axis and the y-axis. So we're comparing x's to y's. And so one of the ways that we'll start writing is in function notation. And so it's nothing different except for saying that now y is going to look like this. F of x. F of x is equal to, and nothing else changes. So if you want to write this down in your notes, f of x is the same thing as y, or output. F of x. Also, when you say, hey, this is how we read it in math terms, know that this is the function when we input x. Notice what we're putting into that function. Try and highlight this real quick. What's put into the function is our variable x. And so in this case, if we look at the machine, the function itself, that equation is the machine. The rule that it gave us was 2x minus 8. And so in this machine, in this case, we want to plug in, it tells us here to plug in a 5. Right, so inside of the function x, we are going to plug in that value to wherever I see x, I'm going to plug in 5 and then continue writing. So the only thing I did is replace x with 5. And so here's where function notation takes place. It says f of x, the function when the input is x. In function notation, our function now has a 5 in it, f of 5. So I replaced x with 5, and what I got, 2 times 5 is 10. 10 minus 8. So f of 5 is 2. So think about that. I put a 5 into the function, and I got out a 2. Our input was 5. Our output was 2. F of 5 is 2. So that relationship is an ordered pair. X was 5, y is 2.